Humbert here, and we're going to be doing Unit 9, Notes 2. So today we're going to be talking about the product rule. So we're basically going to be using the product rule to help us calculate inverse variation. So let's go ahead and let's take a look at what that means. So taking a look at the product rule. So the product rule, basically we're starting with 2 points, kind of like we did with the distance formula. We have x1, y1, and x2, y2, and they're solutions to an inverse variation. Then we can take x1 and multiply it times y1, and that's going to be equal to our k. Likewise, x2 times our y2 is also going to be equal to our k. Thus, the product of the two, x1 times y1, has to be equal to x2 times y2. So then their proportions are also going to be equal. So x1 over x2 is equal to y2 over y1. So then if you look at it, when you cross multiply, you end up getting the same thing that you did up there. Okay, so let's go ahead and let's take a look at what this product rule is going to mean for us. If y varies inversely as x and y equals 4 and when x equals 7, find x when y is equal to 14, solve the inverse variation equation, and then solve. So taking a look at this, so y varies inversely as x. So y is 4 when x is 7. So 4 times 7 is equal to our k. So that means that our k is equal to 28. Then it wants us to find x when y is equal to 14. So that also means that 14 times our x, or just 14x, is equal to 28. So I'm going to divide both sides by 14, and I end up getting that x is equal to 2. So that's all there is to it. That's my answer for number 1. Next, let's take a look at number 2. If y varies inversely as x and y is equal to 4 when x is equal to negative 8. So negative 8 times 4 is equal to our k. So our k is equal to a negative 32. Then it says find y when x is equal to negative 4. So we have that x is equal to a negative 4. That's going to be multiplied times our y, and that also has to equal our k. So we're going to take and we're going to divide both sides by a negative 4. When we take and we divide negative 32 divided by negative 4, that's going to give us a positive 8. So here I get that y is equal to 8. So taking a look at number 3, if y varies inversely as x and y equals 5 when x equals 12. So first I'm going to stop and I'm actually going to multiply those out. Okay, so what I have then is I'm going to sneeze. Sorry if it startles you guys. So 5, wrong one. Come on, Miss Humbert. Good gracious. We're going to start that one over. Okay, so 5 times 12 has to be equal to our k. So our k is going to be equal to 60. It wants us to find x when y is equal to 15. So since y is equal to 15, so 15 times our x is equal to 60. So then we're going to go ahead and we are going to divide both sides by 15, and we get that x is equal to 4 for our final answer for number 3. Taking a look at number 4, if y varies inversely as x and y is equal to negative 8 when x is equal to negative 3, well, I'm going to multiply those two together, and that's going to be equal to my k. So negative 8 times negative 3 is a positive 24. So k is equal to a positive 24. It wants us to find x when y is equal to 6. So 6 times our x, or just 6x, is equal to a positive 24. Then we're going to take and we're going to divide both sides by 6, and I end up getting that x is equal to 4. So our final answer is x is equal to 4. Let's take a look at number 5. Y varies inversely as x when y equals 7 and when x equals 4. So again, I'm going to multiply those two together. 7 times 4 is equal to my k. So I get that k is equal to 28. Find x when y is equal to 14. So 14 times x is equal to 28. So then we're going to go ahead and we're going to divide both sides by 14, and I get that x is equal to 2. So that's our final answer for number 5. Taking a look at number 6, y varies inversely as x and y is equal to 5 when x is equal to 3. So we're going to take and we're going to multiply those two together and set it equal to k. So k is equal to 15. So it asks us to find x when y is equal to 15. So 15 times our x is equal to 15. Divide both sides by 15 and you get that x is equal to 1. So x is equal to 1 is our final answer for number 6. Let's take a look at number 7. So for number 7, if y varies inversely as x when y is equal to 2 and x is equal to 12. So we're going to stop there and find our k. So 2 times 12 is equal to k. Okay? So 2 times 12 is going to give me 24, and that's equal to my k. It says find x when y is equal to 4. So 4 times x, or 4x, is equal to 24. Divide both sides by 4, and we get that k, or x, where did I get k from? X, is equal to 6. So then we get that x is equal to 6 for number 7. Let's take a look at number 8. If y varies inversely as x and y equals 12 when x equals 4, again, multiply 12 times 4 and set it equal to k. 12 times 4 is 48. So my k is equal to 48. So then I'm going to find x when y is equal to 16. So I'm going to take 16 times my x and set that equal to 48. Divide both sides by 16, and then I get that x is equal to 3. So x is equal to 3 is my final answer for number 8. Let's take a look at number 9, earth science. As the temperature increases, the water level of the river decreases. So that immediately tells me that I am talking about inverse variation. Okay, then it asks me to find, it says when the temperature is 90 degrees Fahrenheit, the water level is 11 feet. The temperature is 100 degrees Fahrenheit, what is the water level of the river? So first let's get our K. So when the water level, or it's 90 degrees, the water level is 11 feet. So then our K is going to be equal to 990. So then when the temperature was 110 degrees, we don't know the water level, so I'll just call that W. Those two multiplied together also have to be equal to our K. So I'm going to go ahead and solve for W. And I end up getting that W is equal to 9 feet. So the water level is 9 feet when the temperature is 110 degrees. So it's really not that different. So taking a look at number 10, when two people are balanced on a seesaw, their distance from the center is inversely proportional to their weights. So that means the heavier you are, the closer you need to sit. All right, so if a 118-pound person sits 108 meters, so a 118-pound person is going to sit 1.8 meters from the center, and that's going to be our K. We're going to figure out what our constant is. So 118 times 1.8 is going to give us 212.4. So now we need to figure out how far a 125-pound person should sit. So we have 125 pounds sitting X meters or M meters away, and that needs to be equal to our constant of 212.4. Divide both sides by 125, and then I end up getting M is equal to 1.7, and then it's going to be meters. So a 125-pound person should sit 117, good gracious me, 1.7 meters away from the center. Let's do one that's similar. So two people are sitting on the seesaw. So a 105-foot person is let me just start that one over. Suppose two people are sitting on a seesaw. How far should a 105-pound person? So we don't know how far. That's what we're trying to find. That's not going to help us find our constant. So we want to see how far they should sit to balance a 63-pound person sitting 3.5 feet. That's going to give us our constant. The 63-pound person is sitting 3.5 feet away. So you multiply those two together, and that will give you our K. So you multiply those together and you get 220.5. That's our constant. So the 105-pound person should sit M meters away, and that should multiply to 220.5. Then you're going to divide both sides by 105. And then we're going to end up getting 220.5 divided by 105. You end up getting that m is equal to 2.1. And our label for this one was feet, because that's how many feet we were talking about sitting from the center. So that concludes your note video for today. Go ahead and show me your completed note sheet when you are done. Thanks for listening.